welcome you to this year's 2020 Latham Fellowship. This year, we are focusing on design and data. I'm very excited about having two fellows. And fellows both give a speech, but also then do a workshop with students as well. Obviously, we are doing this very differently than previous years. We decided that we wanted to move forward because all of us probably are looking for additional intellectual stimulation beyond our day-to-day online classes or our Zoom meetings. So we thought this topic would actually be a nice way of using a different medium to share it. And I'm very encouraged by the fact that we have at least 7 international participants who would normally not be able to join if we would do it at Kaplan Institute at our home in the Steelcase Commons. So it's the first time we're doing broadcasting it this way and already have a great benefit. So I'll just do a quick introduction and then hand over to John Cain, our faculty member, to introduce our speaker tonight, Knut. And I'm just going to talk a little bit about what is the Latham Fellowship and particularly also honor the sponsor, Richard Latham. So our Latham Fellowship is about connecting to Richard Latham's philosophy of design planning and are selected because of their ability to challenge the boundaries of design and transfer knowledge about design planning and its value. Fellows give a lecture hosted by ID and share their emerging ideas with the ID community and the wider public by publishing freely available digital content in the form of a paper, article, or this case, a presentation that acknowledges their fellowship. And as I mentioned in the series this year, we have 2 speakers, Knut Synstad tonight, and in a week, please make sure you join as well, Adrian Siegel. So just a little bit about Richard Latham. He was born in 1920 and passed away in 1991. He was an influential figure in design planning and strategic design, and he did study design at Illinois Tech, actually Armour College at that time on the Mies van der Rohe. He served as a director of design of Raymond Loewy Chicago office, and later in the late 50s founded his own firm, Latham Tyler Jensen. Very specialized in product planning and pioneering a new important area and a discipline for industrial designers. So we are talking in the 50s, really, really early, when industrial design was still mostly about form. He thought it's much more about planning. Latham was interested in using design to make a strategic impact on business and believed that the principle of design should be the core of business planning. Committed to this philosophy, he worked only with visionaries who had a deep respect for users and who understood that sustaining their organization depended upon this respect. So with that eye, that's how we select for the Latham Fellowship, and very much focused on pioneering and emerging topics like design and data. So I'm very excited about opening up this series. And with that, I hand over to John Cain to introduce our speaker for tonight. And thank you for joining.
Thank you, Dennis. I'm John Cain. I was recently a visiting professor at IIT and have now returned to as an adjunct, which I've been on and off for the last 20 years. And in coming up with ideas for Latham speakers, given the theme of this year, I had suggested Knut, or someone from an area like the work that Knut is doing, if he wouldn't be willing to do this. So thank you, Knut, and thank you for everyone for your patience tonight as we try this first ever Latham virtual meeting. I think everyone's probably pretty tired of online meetings these days. They are, in a way, kind of exhausting, but hopefully we can get a really stimulating, interesting conversation going here tonight. So I met Knut first about 2 or 3 years ago. I do work on and off with Hugh Dubberly, and I'm frequently out at his office in San Francisco. If you don't know Dubberly Design, you can look him up at dubberly.com. You can take a look at the kind of work that they do. I've known Hugh for a long, long time, and through Hugh, I met Knut when he came in one day to show us some work that he was doing, analytics around logos. And it was kind of understood that logos was a convenient topic. The idea of logos, the graphic, the appearance of logos was kind of a convenient topic for Knut. And I instantly recognized a way of working that is so relevant these days for design and for designers, and thought that Knut would be the perfect person here as one of the Latham speakers, and he's agreed to be here tonight. So in doing a little bit of a biographical sketch here, Knut is Norwegian. He grew up in Norway. He grew up in a home. I've known him as a very curious person, and by that I don't mean suspicious person. I mean, he seems to me to be a lifelong learner, somebody whose curiosity was developed from a very early age. And in chatting over the last few days, he's told me about his path of early computation, early interaction and engagement with computers, going away to summer camps with computers, building a first computer. And in the family and upbringing that he had, I share the Northern European descent. And in my Swedish family, we have something called use it up, wear it out, make it do. And Knut said something almost exactly like that. And so to have a computer was to have to know how to fix it. And I think some of these values that he was brought up with are ways that led him deeper and deeper into how the machine works. In Norway, I don't know that everybody knows, but military service is compulsory. And after he left military service, he was trying to decide between the paths of computation and electronics and digital things and design. He went on to get an undergraduate in graphic design and then an MFA in graphic design as well. An interesting choice of paths, but you can see the way in which his curiosity and maybe affinity for machine ways of working kind of intersects with his love and affinity for design. And I think that'll come out as we get to take a look at his work here. He's been at Dubberly Design Office for about the past 6 years. DDO, as it is affectionately known, Dubberly Design Office. If you take a look at their top page, it'll say that we design software. I think that their work is really much more than that. It's engaged with a broad set of practices of design, from interaction to package to service to product to system design, all in a way to build compelling and coherent strategies for their clients and compelling and coherent experiences for the customers of those clients. Really interesting stuff. I think the best in the world. Along the way, Knut has also made a stop at LiveWork. For my money, one of the best service design outfits out there right now. So he's got a really interesting background. I wanted to get a little bit of his kind of mindset into the conversation here, so that as we take a look at his work now, it's important to see not only of course the logo and the kind of machine and computational way of working that he's going to walk us through, but to understand this as a larger picture here, as a way of working towards a perspective on his subject, happens to be logos, from which he can make observations about the underlying dynamics. Now, everything I just said, you could replace logos with something else, but we're trying to get a perspective on how a system works and the dynamics of a system so that we might intervene as designers. So with that, I'll shut up and turn it over to Knut. I will be back after about a half hour. Knut's going to take us through his presentation, and we will try to open it up for Q&A. A number of you have already submitted questions when you registered for this. I'm going to draw from those questions first, and if we have more time, we can keep going. So with that, take it away, Knut.
Thank you so much. And thank you so much for inviting me. It's quite the honor. I mean, I love talking about the work I do. So every chance I get, I'll show up. Let me see if I can share my screen. Yes. So hopefully you should see everything now.
Since I can unmute easily, I can see your screen, and hopefully that is the same for everyone else.
And you can only see the presentation, right?
Correct.
Good. All right. Let us get going. So today's topic is about AI and computing in design, but I'm going to specifically talk about a project I did over the course of the last couple of years. It took a while, but I did get there. So you may wonder, who am I and why am I here? I'm Knut. I'm a designer, but I also code. By day, I design products, services, and systems at Dubberly Design Office, like John mentioned. But I'm also interested in exploring the applications of AI, machine learning, and computation in design. Now, that has many interesting facets to it. And I don't necessarily mean that it's going to automate the process or remove us as designers, but I do think it's going to rewrite how we view the design process, and I think it's going to do it for the better. My dream would be to have a conversation with the machine, to have a true collaborative relationship with them. Now, John mentioned that before studying design, I was an officer in the Norwegian Navy, where my responsibility was around electronics, maintaining sensors and communications equipment and stuff of that nature. So from a very early on, I've been interested in complex systems and how they work together. And of course, I'm a former graphic designer. This may not come as a shock for most people, but design practice is continually evolving, more so now than it ever has been in the past. What we design, how we design, who designs, why we design, and where we design is all subject to change. And that's really interesting. The advent of digital tools have completely changed how we approach these things, and the internet too. It's enabled types of working that was never imagined before. But if you want to learn more about the evolution of design itself, I recommend that you see a presentation by Hugh Dubberly. It's well worth your time. So in the last 50 years, probably the biggest change design has seen has been computing. Now, of course, this is from 1984, the Macintosh, but there's so much more to computing than just a machine. There's many facets to it. Now, first, let's look at computing as a tool. And as a tool, we can augment the design process. Now, here's a couple of tools you may have encountered over the years, but there's actually quite a bit going on here. So we have the traditional Adobe applications, and then you can draw a line in the sand almost between the old era and the new era. The applications on the right, Sketch and Figma, represent a whole different way of thinking about what you design. We're moving towards nested components. So it's a completely different mental model, but there's another distinction to be made here. The two applications, or the three applications on the right, can be viewed as compositing tools, building something greater, while the two on the left are more pure authoring tools where you can make something that can be used in these authoring tools. I should mention one thing here. That there's an interesting story, of course, about Illustrator. You guys may know it. John Warnock, while at Xerox PARC, developed something called Interpress. This is our precursor to what we know as PostScript. Unfortunately, he wasn't able to commercialize it at Xerox PARC, but after he left Xerox, he went on to found Adobe, where they developed PostScript, and it was a huge commercial success for them. Now, his wife, Marva, happened to be an illustrator and designer at this time too, and John had helped her translate her designs into PostScript so that they can be packaged as an EPS file for use in compositing tools like PageMaker. This ended up taking more time than he probably wanted to spend, so he ended up writing Illustrator as a response, lowering the barrier to entry for creating PostScript. It's kind of a remarkable feat of engineering that a man can do that. As we move further to the right, there's another trend that's happening. We are moving closer to code. It's not too far off, but we are starting to see the beginning of a convergence between design and code tools. So one of the tools that isn't listed here, called Framer, actually has an environment both for coding and for design in the same application. And that's something I think we will see more of as we begin to embrace computing and development in design. Of course, computing can also be used as a medium for sharing information. And I think, a newspaper is a great example of that. Another good example is YouTube, the means of communicating, or Facebook for that matter. Now, computing can also be a material. This one may be less intuitive at first. So the example I'm using here is an application called VisiCalc. Now, I think the easiest way to describe VisiCalc is to think of it as the first digital version of Excel. That may not sound exciting, but before it, there was nothing like it. What it enabled was smaller businesses to do what-if analysis of large scenarios, a type of work that was impossible before this time. But I think Ted Nelson put it well when he reviewed the product back in 1984. He said that VisiCalc represented a new idea of a way to use a computer and a new way of thinking about the world. That's a large claim. There's even videos of Steve Jobs bragging about how they used VisiCalc internally and how they used it to make Apple's financial products at the time. But these three digital transformations are progressing at a different stage. Of course, the tools, they're using the machine as a tool is further along because it's been around longer. Medium, not so much. Material is quite new. Now, for material, it's quite interesting. We see material as Siri, Alexa, these types of products, or something you can directly interact with. I think this is where it gets super interesting for me, at least. But it made me wonder, how are designers using computation or computing as a medium today, or are they? And I was happy to find a number of examples when I started looking. So here's a couple. So my first example is a visual introduction to machine learning by Stephanie Yee and Tony Chu. So this was done in 2015, and it's a designer and a developer, a pair. But they have this wonderful interactive exhibit where as you scroll, the exhibit on the right updates, and the copy on the left describes what's happening and why. But it's the most fantastic thing I had seen at that time, and it blew my mind. Another cool example is, most of the articles from distill.pub. So that might be kind of a weird term, but distill.pub is a publisher for machine learning topics, but the emphasis is on making it as concrete and understandable as possible. So when they made an article about t-SNEs, it's remarkable. It's interactive. It has, it describes many of the pitfalls and what to look for when you're using a t-SNE. Now, of course, a t-SNE, probably a new term, but it's a T-distributed stochastic neighbor embedding. Oh boy, that's a lot to take in. But it's a technique for reducing dimensionality in data. I realize that that's also somewhat vague, but we will get back to that idea and make it more concrete later in the presentation. Now, in 2017 is where I started realizing that, you know what, designers might be able to do this too. So in 2017, Kevin Ho at IDEO, he's a developer and designer combo at IDEO, but he looked at all the typefaces on Google Fonts and he downloaded all of them. He analyzed them by visual similarity and he made a t-SNE map of how they all interacted. And I thought, oh my, it's fantastic being able to see designers do this kind of work. But there was a couple of things that stood out to me. I wonder, well, first off, how did he do it? And can I do it too? But it was a static experience. You could navigate, you could zoom, you could pan, but you couldn't alter it in any way. So it was unclear to me what you would do with it necessarily. Now, what Kevin had represented was, of course, a solution space. It's the space of logo or space of typefaces that Google surfaces through Google Fonts. But this idea of a solution space isn't new. In fact, it goes all the way back to at least Herbert Simon, and we've seen a number of representations of it, but they're incredibly difficult to create by hand. So here's an example from the Vitra Design Museum. So this is the 2018 version of this poster, but they've made this poster a couple of times now where they surface a couple of chairs from their internal exhibit to describe their solution space of the museum. Unfortunately, it only has a small subset of all the chairs they actually have in the museum. They were not able to capture it all. But of course, this is done by hand, so it makes you wonder, how might computing help? So this is when I'm starting to realize, okay, I'm seeing designers start to use these tools, and I'm seeing solution spaces being represented. How can I get in on this? So I thought, what would it take for me to organize the logos of the Fortune 500 by visual similarity? Now, why the Fortune 500, you might ask? Well, I thought it was a small, concrete data set that's relatively easy to collect. And it's a data set many people will recognize. That's essentially the extent of it. Like John mentioned, you could replace this data set with any other, and you can use the same technique there. Now, here we can see all the Fortune 500 logos sorted by rank or revenue, if you will. I mean, that's how Fortune magazine lists the companies. But how am I going to transform this into a map where they're structured by visual similarity? That turned out to be quite the tall order. A sequence of data transformations are required to do it. Now, of course, as I started this project, I had no idea that this would be involved. So my first problem was figuring out what do I need to do? And then I had to learn how to do it, and then I had to do it. But it's really difficult when you're entering a new domain where you don't even know the language. So I cannot even articulate what I'm trying to achieve at this state. So it took me quite a while to come up with this list. And this was not the first list I came up with. There was many failed attempts that didn't make it. But let's go through the steps, and we can see how I actually made the presentation or the visualization of the Fortune 500. So it begins with data wrangling. So data wrangling is a little bit of a cumbersome process. You have to collect the data, you have to clean the data, you have to prepare the data, and you have to morph the data into a format where it's usable for subsequent analysis. So I have to begin by simply collecting the list. So luckily, Fortune 500 magazine, they publish their list every summer. So I was able to go to their website and just copy the entire list. Perfect. Now, using that list and a spreadsheet as a guide, I collected vector logos for each company. And as you can imagine, collecting 500 high-quality vector logos takes a long time, in part because many of these companies don't want their vector logo to be out there. So some of them came from Wikimedia, Wikipedia. Some of them from their corporate websites, if they use an SVG maybe in the masthead. Or I might have to remove them from an annual report they had published a decade ago. It took a long time. The New York Times actually wrote an article about data wrangling and the difficulties of doing it a couple of years ago. And they estimated that 80% of the time is spent preparing the data and only 20% is done on the actual analysis. That wasn't entirely true here, but it did take me the better part of a week to collect all logos. But collecting them is only the first battle. I realized afterwards that for me to be able to do anything meaningful with them, I needed to clean them all up. This was a little bit of a defeating moment for me, but I realized that they're all in different format, AI, SVG, PDF, EPS, and so on to the more obscure ones. But they're all different, and they were all done in different tools. So some of them had padding, some of them had invalid code inside, so that needed to be cleaned up. Some of them had vendor prefixes and stuff like that needed to be removed. So it was quite a bit of work to actually clean up the data after I had collected it. But I did manage to collect all 500, clean them all up, and I wrote a Node.js script that let me take those vector logos and export bitmap logos in the form of PNG at any arbitrary size, which was great because then I could use the PNGs down the line. And at least I knew that each logo would be the same size. Now, that's great. So you have the logos. Now it's the simple matter of just organizing them by visual similarity. I didn't really know where to begin, and I was intimidated by neural networks. So I tried to describe them all by hand, and you can see how far I got before I realized that this isn't going anywhere. I got about 25 lines in, and you can see there's only a couple of columns. It would be an enormous amount of work for me to describe them all by hand. And of course, it depends on my ability to describe the domain I'm in. But I didn't want to pursue this path anymore. It defeated the purpose. I wanted something that could be done ideally without human interaction. I needed the computer to show me how they were organized by similarity. I didn't want to do it by hand because what if I have a different data set tomorrow and I could do it again, which we've done actually. Of course, I was bound to fail doing this by hand. And I found this great quote by Dan Ariely from Duke University that describes why I failed, essentially. So he said that humans rarely choose things in absolute terms. We don't have an internal value meter that tells us how much things are worth. Rather, we focus on the relative advantage of one thing over another and estimate value accordingly. This was kind of a big deal for me because some of the types of attributes of a logo that I wanted to describe was hard to enumerate. But of course, the machine is more than happy to put a number to things. So I had to figure out how to use a neural net. So I reached out to a friend who was skilled with machine learning, Ryan Keisler, and he was able to show me how to use keras, Tensorflow, and a pre-trained model to describe the logos automatically. And it's the greatest thing ever. So the model we picked was one for general image classification. So it can be used for a lot of things. We didn't train anything particularly for this purpose. But we could feed it an image, in this case, a 1024 by 1024 PNG, and we would get more than 2,000 features out. And you can see kind of a demo of what that looks like. But the numbers aren't that meaningful to us. We don't really know what it's describing, but ultimately it's the presence, the quantified presence of 2048 features. The higher the number, the stronger the presence of the feature is. If it's 0, it's just not there. And this all describes the shape, the physical shape of the logo. But we know color is important too. So how could we extract color from the logos? Of course, my approach initially of just describing the top color wasn't going to cut it. But you can use a technique called k-means clustering instead. So we could use the same input, the square image logo, and we could tell it how many colors we wanted it to extract. So I picked 2 colors, and I wanted the machine to extract the 2 most prominent colors as RGB values. So when you give it the Walmart logo, these are the 2 colors you get. There's one thing I find kind of interesting about this. So most of us who work with RGB will notice that, wait a minute, there's a decimal point in here. That's not how we write RGB values. And that's exactly right. The reason is that there's a lot of pixels in here that aren't a solid color. Imagine the anti-aliasing along the line. There's a lot of colors, but so-and-so transparency. So it's not as clear-cut as a human might think. Oh yeah, there's 2 colors here. The machine just sees it a little differently. Now, so far we've extracted features describing the shape of the logos and features describing the colors of the logo. That's a lot of features per logo, but it turns out that they aren't all as helpful as you'd think. There was a lot of noise that came from the neural net. And this may need a little bit of unpacking, because what does the noise mean? It's not noise in the sense that you can't hear anyone because the wind is blowing. No, it's not a communication noise. It's the model is trained for general image classification. So it's trained to look for features that may or may not appear in this data set. So if a feature only appears for one logo, that means it cannot be used to distinguish it from others. Therefore, that feature becomes noise for this purpose. But I was able to use a process called principal component analysis to remove the top 50 features, which actually means most of the features were removed after first. During the selection process, we have to down select how many features we would like to show. Now, this is where we run into another problem. So we've described or we've created features with two different means. Now, if you looked at the numbers that like we saw earlier, and you look for the largest and the smallest number that appears in the shape features, you see the smallest number is 0 and the largest number is 17.26351 and so on. But for the colors, the top number is 255. That means we can't just arbitrarily merge these two tables of features. We have to do some kind of pre-processing first, or color will wholly dominate the shape. That is, it won't really matter. We need to balance them a little bit. So that's kind of what the extent is. The extent represents the minimum value and the maximum value for any given data set. So knowing the extent, though, enables us to remap it between any arbitrary range, which means we can remap the entire data set between 0 and 1. And we can do that before we combine them into a master feature set. And this it helps alleviate some of the dominance or the bias for one feature versus another. But this is kind of cool because at this point, I have 60 or so, or 56 features for each logo. That's cool. What that lets me do is I can now calculate the numeric distance between two logos, which I thought was kind of wild when I started. I mean, how can you put a number to how similar two logos are? But it turns out this is how you do it. So each feature that we described for the logos is a dimension for describing the logo. Where in this dimension does this logo fit? Now, this enables us to use Euclidean distance, and we can calculate the distance between 2 points in an n-dimensional space. And we can then use that to create a matrix of all pairwise distances. That is the distance between all logos in the entire set. So this is super cool. So here we can see a small subset of it. So the black kind of diagonal line represents it represents two sides of the same logo. So obviously Walmart and Walmart have a 0 distance. But if you ever wondered how similar Walmart and Apple are, it's about 30. Of course, the numbers here are somewhat meaningless. I mean, there's no unit per se. But imagine if we took this matrix and we started with Walmart and we started with Berkshire Hathaway and we started making a graph. And we want the line connecting Walmart and Berkshire Hathaway to be 22.65, like the number is. That's fine. Now let's add another logo and another logo and another logo. And we want the space between them to be this number. Over time, we create this kind of unwieldy ball of connections. Of course, it's in more than 3 dimensions, but you can imagine it in 3 dimensions, for the sake of demonstration purposes. But what do you do with this graph? Imagine taking that unwieldy ball of connection and pressing it flat between two sheets of glass. That's essentially what dimensionality reduction is, the T-SNE algorithm I mentioned earlier. That's kind of what it does. It takes something that is in more dimension than we can see, and it can reduce it to the number of dimensions we can see. So here you can see all of those connections from the logos before, and I've kind of squished it down to 2 dimensions, and I've plotted the result. But this is where it gets interesting, because the T-SNE algorithm can be run more than one time, and every time you run it, it improves the solution. And since we can run it more than one time, it means we can track the progress from step to step to step, and we can animate that sequence. So here is that distance matrix reduced to 2 dimensions and presented over time. So here's 600 steps of the machine trying to reduce the error of the dimensionality reduction. Obviously, pressing it flat isn't going to honor the distances, so it needs some time to figure out, okay, how can I stay true to the original intent? So here's what it looks like. What's cool about this is that there's a similarity here with other machine-based techniques. It's that you can see these breakthroughs the machine has. There's a couple of moments of dramatic change. But what's extra cool is that each of those points correspond with a logo, and we could just substitute the dot with the logo and we get something like this instead. Of course, I should caveat that so far the machine has no sense of the size of the logos. It's simply a point in space. It occupies no room. But that means that the logos are likely to overlap, and of course, they'll violate the boundary a little bit. And there's a couple of things we could do at this point. We don't really want it to overlap. It makes it much harder to read. So this was one of the hard moments for me. Okay, now what do I do? I've seen a number of T-SNEs over the years, and I never realized that they always do a subsequent step before they present the results. People always say, oh, look at this T-SNE, but then they leave out this process of cleaning it up. So I wasn't sure how to do that. But I thought, okay, maybe I can do some kind of collision detection scheme where the logos press outward, making sure they have enough room. That seemed super complicated. And it turns out that there's a much simpler solution. By simply introducing a grid and then introducing a rule where only one logo can be in each grid cell, by default, well, they cannot overlap and they cannot violate a boundary anymore because the cell has a size. But there's another problem. How do I know where to move the logos to so they align to this grid? This is an assignment problem. It's an optimization problem. So the way it's done is I look at all the logos and then I try to associate or assign a point to a cell. And the further a point moves, the more we distort the data. So obviously we'd like to keep the distance we move each point as low as possible. But you can then try to optimize this for the lowest aggregate distortion. Which is super cool. And then, here you can see kind of an animation of how it, let me see if I can show that again. Yeah, and then once you've assigned which logo goes where, it's much simpler to do, of course. But this process does distort the data a little bit. And here's the result of that linear assignment process. But let's switch back to the logos and see how it looks from that end. So here's the logos, straight out of the T-SNE. It's just scaled to fit the square I have here. But let's try to assign it to a grid and see what happens to it. Ah, that's much better. It's much easier to read the results now. But of course, this is only one of many solutions for this. So I mentioned that T-SNE, the S in T-SNE stands for stochastic. So stochastic, depending on the usage, can be a synonym for random. So it's an inherently random process, which means even if I ran the algorithm with the exact same parameters, I would never get the same result twice, which is kind of interesting. How can you get the same result, but it looks completely different every time? It's one of those joyful things about working with a solution space. Now, I wanted to go further than the font map we looked at earlier. I wanted to give users the ability to manipulate the solution space. That is, I wanted to give them access to the full space and not just a small sliver of the space. But that's difficult, because in order to give people access to control it, I need to provide a larger context to manipulate it, a user interface. So here's the screens I put together just to be able to do this on the web. So it's not a large web application. You'll notice there's a large introduction. We'll get to why that it's there in a moment. But there's another thing that kind of occurred to me at this point. The steps we had talked about earlier that you need to do to create this visualization, well, if someone changes an underlying parameter, you need to redo everything that happened afterwards. So I need to draw a line in the sand. What do I want to calculate live, and what do I want to calculate after the fact or before the fact? This is where I drew the line. So I want to be able to run the T-SNE in your browser, and then I want to be able to do the linear assignment assigned to grid, and I want to be able to represent the results all in the browser. This means, of course, that if I had moved the line one above, I could have introduced a toggle to enable the user to set the bias between the two different feature types, shape or color. But maybe I'm trying to work my way up the list, so hopefully I'll get there too. But deciding what to do live and what to do in advance was quite complicated for a number of reasons. One, the neural net that I used is not used for mobile devices. It's somewhat heavy duty. Even on the latest generation, 12-core iMac, it still took hours to run the neural net. So it was somewhat unfeasible to run that live. Of course, now that TensorFlow has matured more and there's JavaScript bindings available to TensorFlow, I could have done it, and I could have used a different pre-trained model, maybe ModelNet, to do the same thing. But the amount of calculation is also part of the problem, because it takes time to calculate. Not only does it take time to calculate, but it takes a lot of resources. So I would like the waiting period to be as low as possible so people can experience the exhibit or the visualization. But I want to be able to customize as much as possible. So I wrote a quick prototype, but then I ran into an issue. Every time I tried to run in the browser, my UI would freeze or the browser would crash. So it turns out that there's a limit to how much calculation you can do in your browser before you start blocking the interface itself. So I had to, had to learn something else, right? How do I deal with this? Well, it turns out that even though JavaScript is single-threaded, there's techniques you can use to shift some of the work into a separate thread. The thread is a little bit of a misleading term here, in JavaScript. But using web workers, I could offload the work so at least I don't freeze the interface as you're scrolling around. It's still going to feel responsive. The type of work I'm doing also takes different amount of time. So the t-SNE steps are relatively quick, and aligning it to grid is surprisingly takes a lot longer time. So as soon as I have a t-SNE result, I kick off the linear assignment. As soon as that's done, I update the view. Then I grab the latest t-SNE from another thread, or however far it got, and I start the process all over again. So I have to move data from thread to thread to be able to work efficiently. And of course, the result is an interactive visualization where users can adjust the parameters and find similarities and differences in the logos of the Fortune 500. But it could have been anything. It could have been any data set, as long as we can quantify it. But let's take a quick look. So hopefully you can see my screen still. Yeah, I think you can. So I mentioned that there's a reason there's a lot of text up front here. Well, I had to balance what do I do while the visualization is being calculated. I didn't want to just have a progress bar, so I thought, okay, I'm going to describe how I did the process in excruciating detail, every single step we talked about here. And then as soon as you're ready, you can jump into the experience. And every time you do it, you'll get a different one. But what's cool here is not that you can, pan and zoom and do different things like that. But if you click on the pencil, you can actually edit the visualization itself. So let's first start it without any changes. Well, we got a different result. You can make a larger grid maybe. Maybe remove the padding between them. What's interesting is that this enables you to decide if you want to look at general changes between the logos or something that's essentially you can describe how many neighbors or similar logos there are, which effectively sets the bias between local and global changes. So I encourage you all to check this out. It's fun to play around with. And of course, if you're interested, the code is available on GitHub, so you can see how I did it all. But let's move back to the presentation really quick. So I have another quick thing I would like to show you, another quick example. So in 2006, Bill Drenttel and Jessica Helfand patented the 3x4 grid. It's a weird thing to get a patent on because you might think there is some prior art here, but they did get the patent. But of course, a 3x4 grid forms a solution space too with a finite number of permutations. So it makes you wonder, how many 3x4 grids are there? Can we show them all? So in 2011, Thomas Gaskin, a designer here at DDO at the time, made this great poster showing every single combination of a 3x4 grid. Now, this was an enormously complicated process because how can you determine if you've shown the entire thing? So we had to reach out to a mathematician, Patch Kessler, and the process took over a year, almost 2 years. But we had to have a mathematician write us a proof demonstrating that we had collected all solutions. And then he was able to export kind of each solution as a PDF, which then Thomas painstakingly had to assemble by hand into a poster. And of course, Thomas later went on to study design at ID. So we thought it was a simple counting problem. It turned out to be a little bit more complicated. But there's another little thing we've looked at recently, another solution space. We've looked at Tic-Tac-Toe. So if you ask someone to describe what Tic-Tac-Toe looks like, you might get something like this. You'll probably get a winning line and they'll say, yeah, this is Tic-Tac-Toe. But in fairness, while true, this is only a partial representation. What would it look like to show all of it? Well, that's an interesting challenge. So last year, I made a poster that includes all 765 unique game boards of Tic-Tac-Toe and the relationship between all of them. And unlike the 3x4 grid, which was done almost a decade earlier, this was done entirely programmatically. The entire thing was laid out by the machine. So the data was generated in Node.js, and the poster was laid out using React.js, and it was designed using SVGs. So it's a little small, but here's a closer up, and you can see kind of each game board. And you may wonder, well, how did you fit them all? Well, I had to add some techniques to reduce the size of the space to represent it, because paper only comes in so many sizes, and I needed to fit it on a piece of paper that could be printed. So I needed to remove duplicates and things like that. But what is a duplicate? Well, a duplicate has many forms, but imagine if you start in the top left corner. Well, that's essentially the same as starting in any other corner. So you can see here, at spot 0, the board is empty, and spot 1, you have the 3 unique combinations. So not only did I have to generate the entire tree, but I had to dedupe it based on a series of rules I introduced. And the result is all the unique boards. So they're all laid out in this matrix, which inherently gives them all a coordinate. And underneath each one is the game boards that came before it and game boards that came after it. But of course, online, size is of no concern, and it enables a more traditional representation. This is also done with SVG, but I had to write a custom algorithm to lay it out for me. And I'll just end with this. Increasingly, products are delivered as services, and increasingly services require data and computation. As a result, data and computation have become a media for designing. And design and code have begun converging, like I mentioned initially. And I think it's an exciting time to be a designer. So thank you all, and thank you for joining. I hope you enjoyed the presentation.
That's me clapping on behalf of all of us. Thank you, Knut, so much. We've got a couple questions teed up. This session is supposed to run till 7, and I believe that Kristen has said that probably we won't get the boot. The host has asked me to start my video. You really want to see my face? Hopefully we won't get the boot in 3 minutes here. So let's just jump right in. There's a couple of questions that have come through the chat window and some of the questions that were gathered during the sign-up phase. I said at the beginning, asked everybody to look upon this work both as the logo exercise, but also as a way of working that led you towards a particular perspective, and from that, maybe some insights about what's going on in the underlying data set, in the phenomenon in the real world. And in that sense, we could abstract from this particular data set perhaps to other data sets. So Alex wrote a question, which is, how might this process be different if the data were not visual? In other words, sound or temperature or movement data that might come from an accelerometer. I'm just bringing those off the top of my head. So if you could start there, and then I want to go into a question about what insights did you actually gather from this? And then from there, I'd like to talk a little bit about some of the questions, get you talking about some of the questions from the sign-up part, which is, how might this be generative? So what other kinds of data? What insights did you get? How is this not only analytic, but perhaps generative as well?
Okay, let's begin with the type of data. So in the process, I showed the distance matrix between the logos. And at that stage, it's entirely numerical. It doesn't really matter what I'm looking at so long as I can quantify it. As long as I can quantify it, I can calculate the distance between them, and I can do the same process. So essentially, you can abstract the way the representation in the final form and the underlying data you're using to create it, which means I could have done, the Billboard Top 1000 or something like that, the songs, and I could have analyzed them for similarity, and I could have just used arbitrarily the album cover as a token to represent them in the space. So the representation doesn't need to be visual. It could be anything so long as we can measure and quantify it, which means it could be sound, it could be movement data, it could be anything.
Moving from there into, I think the burning question on everyone's mind is, what's the best opening move for Tic-Tac-Toe? But more seriously, what did you learn from the logo teasing exercise? And then I'm even more fascinated with any kind of understanding leads to some spark of an idea that we might do something differently creatively. So how is this perhaps a creative exercise as well?
Yes, let's start with what I learned. So I learned the hard way, most of this, because I didn't know what I was doing. So most of what I did was failing and failing and failing, and then eventually I would succeed. It's a little bit about persevering. But one of the things I started wondering was, I wonder if I'm able to share my screen again. Yeah, I wonder if you can see this. So one of the things that occurred to me early was, why on earth doesn't it combine the red squared logos and the blue squared logos? And I couldn't figure out what was happening, because in my mind, well, it's a square. I mean, can't you see the square? But of course, that's not how the computer sees it. So the computer looks at this as the RGB channel. So just because you can see a square in the red channel does not mean that's the same as a square in the blue channel. So like, whoa, what does that mean? Well, in reality, it probably means that I should have made my data set grayscale before I did the shape extraction to remove that kind of noise. But that kind of threw me off for a bit. I didn't understand the things that seem obvious to a human is not obvious to a machine.
And so more practically and pragmatically, what about logos? Any observations about logo design?
No, my only observation is, and this is partly my fault because of the construct of how I made it, but I gave each logo a square. I thought, okay, they're all going to get the same real estate. But it turns out that logos have wildly different aspect ratios. So if you have an aspect ratio closer to a square, 1:1, you will appear bigger here. And this made me wonder, how can we balance the visual weight of logos instead? Because this is the way you often see it in logo grids. I don't think it's the best way to show logos. Ideally, so in design school, I was taught, when I did this, when making a grid of logos, you balance the weight of the logos by eye. But what does that mean? I wish someone would have provided me a step-by-step list of how to do it. But maybe you can look at the bounding box for each logo and scale them so they have a same bounding box. And yeah, so that's probably one of the things about the logos I learned. I wasn't particularly interested in looking at the metadata for the logos. Of course, I scraped that from Fortune magazine, so I could have looked at things like industry, where they're located, how old the company is, is the CEO a male or a female? I mean, any kind of arbitrary data point I could have used to dissect this more, but I wasn't that interested in that because it wasn't about the logos. I didn't have any particular interest to see how can I best stand out as a finance startup. But you could do the same thing, right? I mean, you could restrict this to only be a certain domain, and then as a designer, if I'm making a logo to enter this space, how will it fare?
Right. Good. I think that kind of illustrates the jump from analytic to generative. Not that it's a one-to-one relationship, but we can interpretively look at the data set and the layout, play with it, maybe draw some insights, observations about it, and then maybe use that as input to a design process and a creative process. I'm going to skip to some questions as long as we still have people hanging out. We still have 87. So I'm really struck by, and I was chatting with Professor Zach Pino about your work, and we were both struck in a very positive way by your self-taughtness, your deep curiosity to dig and to learn, kind of bravely go in. And I love hearing you say, I didn't know what I was doing. I tried this out, because that's exactly how it begins. And yet here you are, Knut, as a professional designer. You're not a professional coder programmer, and I don't think you'd ever hold yourself out as that. Maybe you would. I don't want to put ideas in your head or words in your mouth, but it seems to me that you would hold yourself out as a professional designer. You meet with clients, and there's an interesting relationship here between the kind of self-taught, if you will, amateur, forgive me, right, of curiosity that draws you into this way of working. And I just wondered, I don't know if there's a question here, but maybe to get you talking a little bit about how do you credibly translate a kind of hacker, tinkerer, curious person in this space, and how do you translate that into your persona as a professional design person when you meet with clients, when you might have to make observations about logo if DDO is doing an identity program or something like that? Any thoughts there?
Yeah, I think you have to show by example. Now, in part because what does it mean to be trained? And does the quality of my training differ if someone read a book as a lecture, or if I read it myself? I'm not sure if one is necessarily superior to the other. So I kind of reject that notion a little bit, and I don't necessarily think people are fully educated. If someone claims they know something, I would argue they do not. That is, if you're not constantly curious, you're going to become irrelevant really quick. So, as a student, I had this kind of naive belief, that, I'm really looking forward to seeing how the professionals do it. Mm-hmm. But the reality is that the professionals are just as curious and as confused as the rest of us. We're all trying to kind of navigate this new environment and what that means for us as a person, my personal career, but then what does it mean for my business?
And how do you think, it's kind of a related question in there, how would this be different if you did do it by hand as a designer, if you could cut logos out on pieces of paper and spread them all out on the floor there at DDO? Can you talk a little bit about a machine approach, an algorithmic approach, a TSNE approach, versus how this might work by hand? And we saw a little bit of that in the early part of you trying to develop a matrix around obvious components of a logo. Have you tried this by hand, and how would you think the results might differ?
I have not tried it by hand. I frankly think I would get a much better result doing it by hand, having a trained designer do it by hand. But it somewhat defeats the purpose, though, because my goal is not the artifact, right? My goal is the process. So if I spent the week, instead of collecting logos, I spent the week collecting logos and laying them out, that's great. Now I have an artifact. What do I do with it? As soon as someone brings in another data set and asks, hey, can you do this for us too? I'd have to start over. I don't particularly like that. There must be a better way. So by being able to kind of codify this environment lets me run at more than one time and actually have an example too. So I wrote this just as a pet project. Let's see, do I have the share screen again? But I looked at some heart data too. So this is kind of the energy usage of the heart. And the question is, can we detect if people have heart disease from it? And of course, the answer is yes. You can look at the way your energy or your heart operates, and you can see, there might be something wrong here. But you can take these types of measurements and you can represent them as a 3D, I think it's called phase space topology or tomology. I'm not sure about the name there, but it creates a 3D model of the energy use of the heart. This is only one view, and it's represented the same way, which meant I could reuse all of my code and then just plop in an arbitrary data set. And this one is much bigger than 500 logos.
And was this for a client project, Knut?
Yeah, I mean, we weren't asked to classify whether or not they had heart disease, but we had access to the data and we were looking at means of representing heart disease. So we were designing an interface. So this was exploratory.
There's an interesting question, both in a couple of the ones submitted in the sign-up phase and then through the Q&A in the chat window right now. You might want to take a look at the chat window with me too. I'll ask this question. You made an observation that anything that can be quantified, this is a really interesting, we could get into a long debate here. I don't know which side of the argument I might take. I might take the side of the argument that everything is quantifiable, but it kind of depends upon what we mean. So the almost kind of computer vision-esque algorithm that you used was looking at features in a visual field, right, in a logo square. We could do the same thing with camera data. We could do the same thing with moving images frame by frame. Is there a dog in this picture? Is there a sign post? Is there a school bus? But what about, like, let's take a super simple example of shampoo bottles. Certainly, we could easily quantify short ones, tall ones, fat ones, wide ones, round ones, square ones. But in work that I've done in the past, we've had social science type folks looking at ideas around efficacy of shampoo as conveyed kind of semiotically, if you will, through color and language and how it appropriates from other fields like science and technology. So some shampoos look like they came out of a lab. Other ones look like they're supposed to be green and healthy. And we might sort of, as people, be attracted to one or more of these types based on their kind of consonance with our own outlook and our own views. How is that measurable? How are things that are kind of inherently outside the realm, that's a dangerous phrase I just said, of quant that are more qualia, how can we move from qualia to the world of quant? Any thoughts on that one?
Well, so this is interesting, right? So I'm going to use Netflix as an example. So Netflix has a graph of how all its content is related, a generic graph of, this is a horror movie with so-and-so actor. This is another horror movie with so-and-so actor. There's ways to draw kind of paths in the data. But in addition to this generalized graph that Netflix has of how the content relates to each other, they also have a graph of my preferences, which you can overlay that graph, which modifies it. So it's completely possible to have two at the same time. That means Netflix is going to recommend different shows to me than it will to you, depending on the prior history and what I like. But that's manifested as a graph. That's a personal graph for me, my Netflix experience, which is different than the generic experience. But you mentioned something about the shampoo bottles that kind of got me thinking too. So we know that certain shapes are easier to hold than others, for example. We know that,
Depending.
Sorry?
Depending.
Sure, but, the shampoo bottle can only be so large, right? Like, for example, we can't all lift a basketball with one hand. Our hands just aren't big enough. But imagine if you took another tool from coding and applied it to design. What if you took a linter and you described something about how you want customers to use your product, and then you write a linter that tests against that?
You might need to explain linter.
Okay, so linter, we've all seen them. For example, if you write something in Word, you'll get that squiggly line underneath saying there might be a typo here or some grammatical error. It's a proofreading, essentially. Someone points out issues in what you've made. But of course, if you can do that to Word, you can do that in code too. You can look at the style, does it function correctly? But you can add tests to anything. So for example, maybe a test for me is, well, the weight needs to be below so-and-so because that's all I can lift. The radius of the bottle needs to be smaller than so-and-so because that's the smallest thing or the largest thing a child's hand can lift, for example. That way, if something changes in the engineering process, it can be automatically flagged saying, no, sorry, this does not qualify. It's a way to do test-driven development and design. We're getting to that point now.
Good, thank you. The quant-qual and qual driving to quant was best exemplified by someone I know who said, well, when your dog is happy, do you have a dog or a cat? Do you know when they're happy? And this began a conversation of even very subjective phenomenon aren't immediately translated to quant, but we might develop some tests. I'm picking up on your point about tests to know, if you will, if a dog or a cat is happy. We kind of know that instinctively. I'm going to move on to a different sort of question. We still have a good 70 people here. Thank you all. I'm going to go to the Q&A window, a question about design pedagogy and design education. In your estimation, are we good? What do we need to know to work this way? Do you think design education's up to snuff? How did your own compare? Where do you think it's going?
The short answer is no, we are not good. So the reality is that design education is only so long and there's only so much content you can fit in. The downside is that design as a profession is diverging dramatically at this time, which makes it really difficult to make general practitioners who knows all the formal things, typography, composition, color, and these things, but then also knows how do I do things with the web digitally? How do I work with data? How do I do user research? For example, a common thing is maybe you graduated as a graphic designer, but you want to move into user experience research or user experience design or service design. How do you do that? That's a huge thing, and it's incredibly difficult. It kind of locks people in to a path. And for myself, I went to a very traditional visual design, form-giving school, where at the time when I went there, things of a digital nature was somewhat of an afterthought. Yes, maybe you needed to make a little website just to check the box. We had a digital deliverable, but that was always secondary to the visual design. And that's a little unfortunate because I think it does students a disservice entering the market. It's going to be really difficult to... People have this view of the world that when you leave school, you will be prepared to do a job. That is no longer true. So it becomes really difficult for these companies who want a very specialized type of designer, but then where do you go to find that type of designer? It's incredibly difficult for everyone. It's frustrating for students. It's difficult for employers. And educational institutions are kind of caught in the middle, How can we can't endlessly tack on more classes because it's going to extend the program. It's going to get more and more expensive. And we can't necessarily cut things from the beginning either. So what does a designer need to know?
Yes, please tell us. 30 seconds or less. No pressure.
I think people need to have formal skills because formal skills lends itself to rhetoric too. So you need to be able to have a good argument, both written and visually. And I think you should be able to use data. And by data, I do not necessarily mean you should be able to develop things or program things on your own, but you should certainly be familiar with the methods and the techniques that's involved.
And how did you do that? What do you mean self-taught? Where? How?
So I started early. So I started, in the early 90s with HTML and CSS. So I was fortunate that, at a young age, I started learning these things, and I just kept it up over the years as, more and more versions came out. But it wasn't until I started at DDO that I wanted to learn JavaScript. So this is fairly recent for me too. I only ventured into JavaScript 6 years ago. So I used a site called Code Academy to learn, and a book called Eloquent JavaScript, and I thought it was fantastic.
Would I think it's fantastic?
I thought it was fantastic. I think you would like it.
No, and my point is, what if we don't think it's fantastic, but we want to gain some kind of literacy in this way of working, or we want to work alongside you and know the capacities of what it means to work this way algorithmically, algorithmic thinking, if you will, or of horrors of an idea, on how to think this and approach problems in this way, even if we're not doing the programming. Is that possible?
Yes.
Okay.
Absolutely. So I don't think, so one of the big problems people have when trying to learn something like development is, where do I start? It doesn't really matter, because, when I started this, I wasn't a great JavaScript programmer, but I had a big goal, and I just kept with it, and I learned things along the way, and I'm a much better developer for it. I think you just need to pick a project that appeals to you and stick with it. You'll figure it out how to solve it. Ask maybe a computer science friend. So how would you do this? And then they might point you to something, and then you get one step further and one step further, and then just not get discouraged along the way.
And for the remaining 66 people that are still hanging with us, you will answer any and all of their questions as they struggle through this. Is that correct? Blink twice.
It depends how many questions we have, I think. But
okay,
of course,
we'll move on to the next question. I do think that you're probably open to taking questions ongoing if people want to try to reach out to Knut through email. There have been a couple of questions about, so awesome, you've gotten this far, what's next? Both for this kind of work, and then for you in particular, there were a few questions about what's next for Knut. What is he learning now? And then if you could talk about the larger and the more tactical in terms of this project and its ilk. What's next?
Well, so I've worked on this project for over 2 years, off and on, not continuously. And that's the way I like to do it. I like to have more than one project I'm working on at the same time. That way, if I get demoralized or discouraged doing one, I can just shift to another for a while. And then, I'll lick my wounds and I'll try again later. But there's still things I would like to do with the Fortune 500 thing. I want to balance logos by weight. I want to be able to offer the ability to shift bias between color and shape. But that's still in the same vein of exploration. I also want to explore other things. So I've made a couple of things looking at solution spaces, the logo thing being one, the Tic-Tac-Toe poster and website being another. But I've started looking more at generative design and how can I use computation to do design for me, not just look at these kind of things. So lately I've been researching genetic algorithms and ways of applying that to traditional graphic design problems. So it might be the assignments you got in your first type class. I'm looking at how can I have a machine do that for me. And that's really, it turns out to be difficult because it shifts the nature of my work, because I don't think anyone studies design hoping to design presentations or business cards or letterheads, right? I mean, that's not why people study design. They want to make an impact. They want to do something meaningful. So if we can...
Sorry, please continue.
So if we can have the machine do some of these low-end tasks, we can move up in the type of work we do. We can upskill designers and we can work more abstractly. Instead of me designing the business card, what if I simply described what the business card should look like? And then the machine can figure out how to lay it out. And then, it can generate, hundreds or thousands of options. And then I can say, these are good, these are not good, and then go on, try to make something better. So I would rather try to shift into an art director role where the computer is my intern or junior designer.
What happens to the profession? Let's just look at graphic design. We could certainly extrapolate to service, system, product. What happens when we become out of touch with the materiality of the stuff that the practice is constituted in, if that makes sense? We don't know ink. We don't know cutting letter forms out of lead. We don't know offset printing. We don't know the technique and la method. We get out of touch with that stuff. What then, if you look at Autodesk Dreamcatcher, you can make 1 million permutations of a bicycle frame. What happens to the role of the designer? There were a number of questions along these lines.
I think it depends, right? So you said if you're not staying up to date, so I think we should draw a distinction between someone who keeps up and someone who does not. I think if you do not keep up, design as a profession will shrink because more and more tasks will be automated, which is fine. It's going to be, at least at first, the things you probably wouldn't want to do anyways. But it means we won't need as many practitioners to do the same type of design that we have in the past. I don't think this means the designer as a profession is going away. On the contrary, I think there's a bright future for designers, but it's going to shift. We will be less concerned about giving form to items and more concerned about describing the outcomes we would like. That is, I think most designers will become an art director more. You will be more concerned about writing, about rhetoric, building arguments. And that's universal.
Can I ask you to tack onto that with some timely questions that are coming in about the age of C19, online, remote, and distance learning? When we're not in a shop together, what is the Bauhaus shop of data as a material? How can we work on that remotely? Is studio learning dead in that sense? Or is it extremely challenged in the time when we can't get to a shop and can't get to a studio? But please.
No, I think that's kind of the joy of this new world. So we are seeing, I mentioned that design and at least front-end development is converging because we now have tools and we've had tools for a long time that can do both, and they're doing it better and better and better. So at some point, there's going to come a point where there's diminishing marginal returns for hiring a front-end developer. Like, surely the code you get is good enough. But one of the benefits of kind of learning or incorporating more techniques from engineering is that many of the problems facing design today, they've dealt with for a long time. So for example, these days, the idea of design tokens is really important. Yeah, it's a really cool idea. What if you can extract the color out and store it elsewhere, and then if you update the color, your entire identity system is updated. You can abstract away these key values, which of course a developer would call, well, it's a variable. And yes, it is. But now these techniques are making their way into design. It's helping us deal with design at scale. So another thing is in development, there's a principle called do not repeat yourself. Okay, if you can generalize something so you can reuse it, that's perfect. But we haven't really gotten there in design until a couple of years ago when you saw applications like Sketch and Figma come in. Because now you truly have reusable components like we never had before in history for design. I mean, even in Illustrator, sure, we have symbols, but you can't override them or alter them between instances.
There's an interlocking and another question that just came in, kind of to drag it back for a moment. Your BFA, MFA is extraordinarily instrumental and important in your ability to think like, as you call, a design director. Would you say so?
Yeah. Another kind of downside here is that there's so much research happening in the field of AI, machine learning, computing. The downside is that the bulk of it is being done by people who study computer science. Now, it's not that that's necessarily so bad. I mean, they do great work. It's just they're focused on the problems they face. Mm-hmm. We have different problems. And sadly, there aren't that many designers looking at how can we borrow some techniques or best practices from computer science, and how can we apply them to design, and how might that change design practice? So I think there's some, there's a lot of work to be done.
Gotcha. We still have 56 people, so if you're game, Knut, we'll keep plowing here through questions. You have a heart on the desk behind you.
I do.
What is that?
Well, so I mentioned that we looked at ways of representing heart data. And of course, being a designer, I don't know much about the heart. So we thought, we would buy a model so we could better understand how it functions. But our goal was to figure out how can we create an interface for cardiologists. So we needed ways to indicate where there's an error with the heart. So, that's when you break out other kind of illustrations and have kind of cone diagrams of the heart or the blood vessels in your heart and how might that work. And it turns out that representing heart data is really difficult because all hearts are different. That is, we have the same general structure. You have kind of a main input and main output, but the way the heart itself receives blood, the heart that powers the heart, or the blood that powers the heart, is unique for every person. So it's very difficult. There's some patterns, but it's very difficult to represent that as an interface. So we needed to have we needed a systems view of it, essentially. So we thought, we'll start with the actual heart.
Excellent. And the heart data that you showed earlier is related to that project.
Yes.
There was a question. This is an easy one to knock out about the Netflix. Oh, it went away. Perhaps it was answered. Is the Netflix work that you did published?
Oh, no, I did not do any work for Netflix.
Okay. I'm sorry.
But most of these companies, most of the largest tech companies these days are operating a graph of some sort. The thing that makes Facebook valuable is their social graph. The things that make Google valuable is their knowledge graph. But of course, Netflix is also a graph-based company. But they're less focused on the graph and more focused on the nodes of it, essentially. The
Something we ought to be teaching in design school.
Yes, I mean, imagine if you had access to your own graph in Netflix and you could alter it to be able to give yourself better recommendations. Why can't you alter that data?
Because of decisions made by a few people to not allow you access to screw with that data.
I mean, yes, there's a lot of business reasons why they don't do it, but it's unfortunate because...
Yes, I'm not saying it's the correct one, but yes, that's how that came about.
I mean, the customers would benefit, but it would be difficult for them to create.
Good. Do you want to take a look at the Q&A window? And do you see anything in there that I don't want to be the sole conduit here of chooser and picker of questions?
Oh, there's one interesting question here that it's hard to think like a design director without the low-level graphic design experience. That's exactly right. Which is why I think it's important that designers get involved in applying AI and machine learning to their problems, because when we do something, we will have a different sensibility than a computer science person will. When we design, if we get involved in a design system, we can see things they may not see. I think all of us might have made something and then had an external developer make it. And they say, it's the same, right? And then when you look at it, it's like, no. I mean, as designers, we've trained our eyes. We're used to stress about the small details. Many others may not see that. So it's important to have this kind of foundational knowledge of graphic design. It's incredibly helpful. But that's kind of what makes it so difficult, because if that part is helpful, then what do you remove to add data literacy to the education? Mm-hmm. It's like...
Yes. What is the new foundation program?
Yes.
there isn't a right form, but there are form languages. We need to be conversant in those. We need to know something still about production.
Yeah, I mean, we talked about this a little bit earlier too, about how do you gain credibility. And I think kind of design, sadly, is often taught in art schools, which comes with some connotation, right? I mean, I think everyone knows the memes, right? I mean, go to art school and then people say, you know, I hope you enjoy your job at McDonald's or something when you graduate. I mean, people think it's going to be a waste of time. So we have this kind of stigma of how art schools are viewed, and I think it's a huge downside. We have to battle that stigma to say that we have something to bring to the table too. So I think, you know, separating design and art, I don't view what I do as art as all. I mean, I'm not an artist. You know, frankly, I get a little upset when people classify me as an artist. No, that's that's not it at all.
That's a very lovely way of imagining the kind of directionality here, which is it's not an oh shit moment like designers better get coding and data. It's the sensibilities that we can bring to that work.
Yeah, so one of the things is, you know, whenever we have engagements, probably one of the largest services we bring is, you know, we have a new project, we come in, we interview all the stakeholders, and then we try to play it back. We heard you say ... But we try to do that pictorially, maybe through a diagram. Then what's funny is that the people you interview are likely to have opposing views of what they're building. They'll think, sure, the team is aligned on what we're building, but when you actually start to look at what they're doing, they are not. So when we produce an artifact saying, this is what we heard, it's kind of remarkable seeing almost a fight break out saying, no, this is not it, because you can see them all realizing, oh, we have different views of what we're building. And I think in that moment, they all recognize the value design brings to the table.
Good. Do you want to pick from the list? Or if anybody else has questions or new directions, please contribute. I don't mean to skip over any. I was trying to make connections between questions and try to get two birds in one stone kind of thing going.
Yeah, let's see if I can.
What is the best place to start on Tic-Tac-Toe? Come on, I need to know this. I've got a game to later on.
So do you know the XKCD comic?
Yes.
He drew a comic with a blueprint for every move to make and when.
Okay, thank you.
But the reality is, if you are awake, you can always force a draw regardless of where you start. So even if you're the second person to start, if you want to force a draw, you can force a draw. It doesn't matter. It's not a skill-based game.
Okay, I see that my question dropped 4 people from the call. So let's get back to better questions.
Oh, there's a question from Christopher Swan. Could you add different weights to the logos? Yes, you can absolutely do that. You know, I could look at like you said, the revenue. I could look at where they're located, how their history. It's essentially somewhat arbitrary depending on what I want to learn. Oh, this is a nice one from Tomoko. When things aren't going my way and I need to look into something, what do I do and how much time? I would argue that the vast majority of my time is spent redoing the same work over, just better. So I find myself, when I do this kind of work, well, first you have to learn, okay, I guess there's a thing called an optimization problem. All right. What ways are there to do that? Then I'll try to find the simplest one just so I can, get something. Then you'll figure out, no, there's a better one out there. But of course you won't know that until you try it, because So I find myself redoing the same steps over and over and over again, which isn't so bad. It just lets me learn more about different ways of solving the same problem. But I think the biggest thing is just don't get frustrated if you get stuck. It's better to just put it down for a month or two and then, pick it up again when you feel motivated.
Thank you. Kristen, do you think we ought to wrap it here, or do we want to go for a few more? And that's a Knut question mostly.
Here's an interesting one. How has your experience in electronics contributed to your role as a designer today, apart from learning to code? It's been incredibly helpful because an example is here at DDO, we are often involved in designing systems. Systems often have feedback loops. Now, there's many ways you can represent a system. Of course, you could use systems dynamics or cybernetics, but it doesn't really matter. Let's say we pick a feedback loop for now, cybernetics. That's also something you see in electronics. There's only so many kind of patterns, but I see a lot of similarities in how you diagram electronics and how you diagram in design. You can see how signal processing has been incredibly helpful for me to do this kind of work. Oh, this question, the maximum number of projects I'd like to have going at once. No, in part because I have an obsessive personality. So when I decide that I want to do something, I find it incredibly difficult to suppress that desire to work on it. So it's often not in my control how many projects I work on at the same time. So I find that, I don't know, I think I probably have 3 or 4 projects, major projects at the same time. But, I could take half a year off one if I get stuck. Oh, there's a question about, from Cameron. Oh, that's great. Hey, Cameron. See, it's kind of asking how I'm implementing this into design practice. And I'm doing it more and more. It's slow going, but every once in a while we'll find something that can be done programmatically, and it delights the clients because they don't think we can do it. But it's always fun when you can lay something out programmatically. For example, I worked on an identity project just recently, and we needed some patterns. So I thought, surely we can make the patterns programmatically, right? So I wrote custom algorithms for them to generate proprietary patterns that they could use in their own branding. So it's fun to see, it going from this little research project, this little hobby thing I had, and now being able to apply it to work. I mean, it's really exciting to see that.
This is the Latham Through the Night program. We'll be here till 4 a.m. with your questions.
Yeah, I mean, there's a lot I would like to do with the Fortune 500, time series and stuff too. It's just that I collected the 2017 list, and it took me, I think, four full days to collect all the logos. So the prospect of doing something over time means collecting more logos, which is it's just work I would rather not do. So if I'm going to do something with the Fortune 500 over time, or to see how a brand has changed, I think I would have to collaborate with others to do that, or crowdsource it somehow. So the question about noise in the model, I'm not sure if I have a good answer for that, actually. I wish I could describe more about the noise. I wish I could tell you, I reduced the neural net features from 2048 to 50. I wish I could say how many are meaningful instead of arbitrarily picking 50. But I don't know how to do that. That would be really fun to learn. Yeah, I think the last one is learning and teaching data-driven analysis. Yeah, I think it's difficult. I think it's something that's incredibly helpful to designers. I don't know if I have a good answer for how to address it in education. No, I did not try scikit-learn, so I don't know Python. But of course, Python is somewhat human readable. So being familiar with other programming languages, you can read it, but I don't know the syntax by heart, so I have a hard time writing it. But
Don't know
I reached out to my friend Ryan Keisler to help me with the neural net. He does most of his work in Python, so he picked keras and TensorFlow for me. So I would love to learn more about that. Another example is, as soon as I made this with a t-SNE, someone said, "Oh, that's so last year. There's a new technique now." So
Good. Last one popped into Q&A that admits it's not a question. Very true. Some of the most brilliant people that I've had the pleasure to bump into that are developers and programmers doing interesting things are like Knut, very self-taught. It's widely understood that places like Google, many of the Silicon Valley-based firms do not require a degree in programming to have a job as a programmer or developer there. Interesting.
Well, there's even anecdotal kind of stories, right, from the founding of Facebook. So Mark Zuckerberg hired a number of friends to work for him, and people told him, shouldn't you pick more experienced people? And he said, no, these people have been programming since they were 10 years old in their bedroom. Even though they're still in school, they have more than a decade of experience. Why would I look anywhere else?
All right, Knut, I think we will cut it there. A record 7:46. Thank you so much. Thank you for being a good sport. Not only all of the work that you put into a fabulous presentation. Wait, participatory design question. I can't resist it. I don't know, Knut, would you mind?
No, that's fine. It's the last on the list.
Really great LinkedIn post by Amanda today, by the way, that people want to go see what she's up to. It's just phenomenal.
That is a great question. That would be fun. I mean, of course, as an office, we're interested in design processes. So we have a book actually collecting design processes. It would be really fun to do analysis on more processes too.
Let's do it, she says.
Yeah,
okay, so I was giving you thanks and praise for all of I know you've been working on the presentation for a long time, so thank you on behalf of all the participants, the remaining 38 of us, and those that left already. If people want to get in touch with you, I know this recording, Kristen has answered the question, it will be up, available for the participants. I believe the slides as well, Knut, to your understanding. I believe also there is an email address for you if people would like to reach out and get in touch. Is that okay?
That is fine. Maybe I should just type that in the chat so people can see it.
Excellent. Such a great way to spend a shelter-in-place evening.
Yeah, exactly. And of course, feel free to reach out on, by email or Twitter. I'll share the presentation deck on Twitter, so you can download it if you want.
Great. And I know we have the second of the two Latham series panelists coming up. Kristen, please remind me, because I don't have windows open right now. Is it next week? There she is.
It is next week. Here I am. It's next week, same time, April 15th at 8 p.m. at 8 p.m. at 6 p.m. with Adrian Siegel. So please join us again.
Great. All right, everyone. Thank you so much for your time this evening. Stay safe and healthy. And thank you for putting up with yet another online video chat presentation. See you all soon.
Thank you. See you all. Have a good one.